All right, so today we are going to talk about parallelograms. So for parallelograms, you are going to be able to recognize and apply properties of the sides and angles of parallelograms, and recognize and apply properties of the diagonals of parallelograms. So we talked about diagonals last time. Sides and angles should all be familiar terms. But a parallelogram is a quadrilateral, so it's a four-sided shape with two pairs of parallel sides. So two pairs of parallel sides. So probably looks something like this. Not like that. Should have drawn it smaller. I would have had a better shot. Something kind of like that, generally. And you have two sets of parallel sides. So we have this set's parallel, then that set's parallel. And then each set of parallel sides is also congruent to each other. And you also have two pairs of congruent angles. So we have the acute angles are the same, and then the obtuse angles are the same. So a lot going on with parallelograms. Important thing to remember is it's quadrilateral with two pairs of parallel sides. All right. So now we get into our properties that I just talked about a little bit. So if a quadrilateral is a parallelogram, then the opposite sides are congruent. So in this case, JK and ML are congruent, and then JM and KL are congruent. 6.3 says, if your quadrilateral is a parallelogram, then the opposite angles are also congruent. So in this case, we have K and M are congruent, and then we have J and L are congruent. Since they are opposite, they're connected by that diagonal. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. This is a big one that people oftentimes forget. So if I add two angles in a row, whether we're going up and down, left to right on bottom, left to right on top, up and down on the left side. If you add two angles in a row, one of them's usually acute, one of them's obtuse, then added together, they equal 180 degrees. 180 degrees. All right? If a parallelogram has one right angle, then it has four right angles. So if one angle in a parallelogram is a right angle, then you can go ahead and say all of them are right angles. And the reason for this is, so let's just say we know J is a right angle. Well, we know L has to be congruent to angle J, since they are on opposite sides connected by that diagonal. So those two angles are congruent. And then they also told us that consecutive angles are supplementary. So in this case, we'd have 90 plus angle K equals 180. So if we solved for angle K, we would be left with angle K equals 90. Which, if angle K was 90, then we would know angle M is 90 as well. So essentially, big picture, if one of the angles is 90, then all of them are 90. Opposite sides are congruent, opposite angles are congruent, and we have two pairs of parallel sides, as the name would suggest. Continuing on. So, construction in parallelogram ABCD. Suppose angle B is 32 degrees and CD is 80 inches, and then BC is 15 inches. We're supposed to find AD. So we know BC is congruent to AD. We know, well, I guess that's all we need to know for this one. We could also find that DC is the same as AB, angle B and angle D are the same. Angle A and angle B add up to equal 180. In that case, angle A would be 148 degrees, 148 degrees, and angle C would be 148 as well, since they are congruent. So for this question, we just filled in all of the missing measurements by only knowing that this is a parallelogram, one angle, and two sides. So I guess we should answer their posed question. Line AD equals 15 inches. Now, we have the same situation on this one, but they want to know angle C, which we already said angle C and angle A are 148 degrees. They would also like us to tell them what angle D is, which we said angle B and angle D were congruent, and angle B is 32 degrees. Therefore, the measure of angle D must also be 32 degrees. So ABCD is a parallelogram. Find AB. AB would be 30. ABCD is a parallelogram. Find the measure of angle C. Angle C would be 36 degrees. Find the measure of angle D, which would be 144. Delightful. All right, now we have some rules for the diagonals of parallelograms. So if a quadrilateral is a parallelogram, then the diagonals bisect each other. So they cut each other directly in half, meaning AP and PC are the same, and DP and PB are the same. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So we haven't talked about area or anything yet. We'll talk about this again when we get to that point, but essentially your diagonal, if you have only one diagonal, like we do here, BD, then this lovely red half over here is going to have the same area as this blue half over here. All right. So if WXYZ is a parallelogram, find the value of R. What? Cool. So we know ZY is 18, which means WX is also 18. So if we would like, we can just set 18 equal to 4R. So I would say 4R, that was a horrible R, we'll try that again, equals 18 degrees. Divide by 4, and R would equal 4.5. All right, same parallelogram. Now they would like us to find the value of S. So we know 8S, or this half of, that was a horrible line. I'm just not on my game today. So we know Z to this middle point and this middle point to X are congruent. So we could say 7S, I hate when they use S because they look like fives, 7S plus 3 equals 8S. Therefore, S would equal 3. All right. If any of you ever grow up to be textbook designers for math, please do not put any O's or S's in there. And really, if you're going to do an L, make it cursive. Some of my pet peeves. And apparently I can't make R's very good, so maybe leave those out too. If WXYZ is a parallelogram, find the value of T. So, where are our T's? Cool. So, right away, so this is a parallelogram, right? So we have ZY is parallel to WX. Now, I'm going to draw in a red transversal. I'm going to attempt to draw in a red transversal. So we have one line that's cutting just happened? That's cutting through this pair of parallel lines. So we have that parallel line. We'll just extend this just so it makes it look a little more familiar. So we have the two pairs of parallel lines, or we have one pair of parallel lines in this case, and we have a transversal, or something that's cutting both of those. We know, based on alternate interior angle theory, then 2t, this angle right here, would have to be congruent to this angle right here, which would be 18 degrees. So we could say 2t equals 18, or t equals 9. Lovely, lovely. So if ABCD is a parallelogram, find the value of x. Cool, cool, cool. So very similar to the first one we did, we know b to this midpoint is congruent, and we know d to the midpoint is congruent, meaning that 4x plus 12 is going to equal 6x plus 2. So if we set those equal to each other with not the highlighter, if we say 6x plus 2 equals 4x plus 12, then we would end up with 2x equals 10, or x equals 5. Lovely. Continuing on, so now they want us to find p in the same parallelogram. So where is the p? So we have line AB and line DC are going to be congruent because they are opposite sides on this parallelogram. And they're also going to be parallel, but that doesn't do a whole lot for us here. So we know 2p is going to equal 22. 2p equals 22, aka p equals 11. If ABCD is a parallelogram, find the value of k. All right, so now we're back to our little examples of, we have parallel lines, DC and AB are parallel. So let me draw my little arrow in to show that. And then grab my red here, and I'm going to draw in the transversal that's cutting them. So I know, based on alternate interior angles again, 3k plus 4 is going to equal 25, since they are on opposite sides of the transversal and they both lie in the interior. So that being said, I would say 3k plus 4 equals 25. So 3k equals 21, which means k equals 7. Yay. All right. What are the coordinates of the intersection of the diagonals of parallelogram MNPR with vertices? You can read them. So, is this the same thing? Yeah, no. 0, -3, -1. So these are different problems. Okay, so right off the bat, what I'm going to say is graphing this on graph paper seems like a chore to me. So what I would do is I would do this on GeoGebra, which I will send out I will post a video of me doing that on GeoGebra so you can see that. But I would use GeoGebra for this problem, and I would also use it for this example 3. I would familiarize yourself with GeoGebra because I believe it is a great tool for geometry, and it can also be a great tool just going forward in math because it's always going to be accessible on your Chromebook. So I think any practice you get with it will be ideal. So there will be a GeoGebra video posted directly after this one in the same folder. So